All right, in this section, we're going to talk about normal distribution, which is the most commonly used distribution. And this is slightly different than what we talked about last time, which is binomial. And this corresponds to book section 6.1 and 6.3. So arguably the most important distribution we're going to study in this course is normal distribution. In the normal distribution, most of the values are clustered around the center or the mean, right? So center, which is the mean, or the average, right? Average. Very few of the values are extreme. It means few values are either too big or too small, way too small, right? Like outliers. We call these extreme parts of the distribution the right and left tails. And the graph of the normal distribution commonly known as the bell curve. So let's kind of fast forward to a picture here for number 4. So what they're saying is, if you look at the graph, you notice, first of all, graph looks kind of like a bell, like a Taco Bell. Yeah, it's like, yeah, there's a bell. Okay, bad graph. So that's why it's called bell curve sometimes. If you look at it, you see the little line in the middle. That's basically the mean, which is the right in the center. That's an average. And you notice that the graph is pretty tall in the middle. So most of the data set is clustered in the middle. If you go out from the mean, you see the little tick mark. It's the standard deviation. So 1, 2, 3 standard deviation. Your graph is basically flat on the. So in this area, there's not much there, right? So first of all, we are not using like bars as before. We're using just one curve, right? But the concept is the same. Like here, we have a basically small, very small area. That means there's not much there. In the middle, the area is pretty big because graph is kind of tall, right? This end, which is called tail, right? So this is left tail, this is right tail. Again, the area is not much there on the left tail, so that means there's not much there because your graph is low. And by 3, your graph is basically 0. Theoretically, graph goes forever to the left and graph goes to the forever to the right. But you just don't draw it just because, you can't draw forever. All right, so that was a graph of the normal distribution. Let's go back to number 2. Normal distribution depends on 2 numbers. The mean, symbolically is mu, mu, and we'll write it like this, right? It kind of looks like u to me, if you ask me. And the standard deviation, this letter is called sigma, right? It's like 6 sideways, like this, right? So if I were to look at the graph, basically it's gonna be like the one in the middle is gonna be mean. So if I were to use the symbol, I'll use the mu. And notice the tick marks. Each tick mark is by standard deviation. So this is like standard deviation, this is standard deviation, this is standard deviation, kind of this way too, right? So on and so forth. All right, number 3. Before studying general normal distribution, we'll first study like a special case, the standard normal distribution. I'm going to underline standard. This is case where we have the mean 0 and the standard deviation 1. So this is basically z-score. Because when we talked about z-score, we had 0 in the middle and then we went by 1, right? So z-score is just, if I put the direct graph of it, when we talk about z-score was 0 in the middle. Then we went by 1, 2, 3, 1, 2, 3. So 1, 2, 3, negative 1, negative 2, negative 3. So when we did z-score, we're talking about standard normal distribution. Okay, symbolically we can write it n for normal. I write 0 and 1. So this is mean, that's standard deviation. So basically what it says is, we have something that's normally distributed with 0 as a mean and then 1 as a standard deviation. That's standard normal distribution. As I mentioned before, we're writing the z-score for standard normal distribution. Okay. So now we're going to try to calculate different areas under this curve. So similar to the uniform distribution, calculating the probability in the normal distribution is same as finding the area. So what we're going to do is basically, this is kind of important concept, we're going to equate area to probability. So in this section and the next few sections, we're going to have a lot of probability questions. And basically, we're going to translate our probability question into area question. That's why we have this graph. Because if we have certain area has high probability, that means this has a lot of area because the graph is tall. And if certain area has low probability, that means this area is very small. That means it's very small probability, right? So we'll translate probability question into area question. And we'll look at the graph and try to figure out the area. All right, so shade in the area corresponding P -2, z-score is bigger than -2 and less than 1. So -2 is here, I'll mark that. And then 1 is here, right? I'll mark that. And notice this, first of all, is z-score. So 2 is here, 1 is here. So basically what this area is between -2 and 1, so this part, right? Because we're talking about probability, the area of the whole thing is 100%, right? You notice this is half, so this half is 50%, this half is 50%. And part B, we're going to try to estimate the area we just shaded. So again, as I said, if this whole thing is 100%, I can feel like this is more than half, maybe like 60 to 70%. So I want you to have an idea of how big this is. Obviously, so like here, let's try to just to play around here. 90%, 90%, right? So I feel like it's definitely more than 10% because 50% is half. It seems like it's more than half. So not this, not this. So I feel like it's 70%, 90% is like a lot. It's almost like 100%. So maybe it's not as big as 90%. So if I have to guess, I'll guess 70%-ish, right? So, okay, how do you now precisely calculate that? So we're gonna use our TI-84 calculator. So what we're gonna do is you're gonna do, there's a separate video here too. There's a separate video. There is a separate video. So what we're gonna do is you're gonna use second. And we're gonna go vars, which will give you the distribution. That will go to normal CDF. It asks for lower bound, upper bound, mean, and standard deviation. Right, so these are 4 numbers you need to input. So for example, if I were to look at the example we just talked about, like here, our lower bound is the lowest number in your area. So this is the area bounded by -2 and 1. The lower bound is like the left endpoint, basically, it's -2. Upper bound is 1, and the mean was 0, and the standard deviation is 1, right? So if I were to do that here, I'll plug in lower bound as -2, upper bound as 1, mean as 0, and standard deviation as 1. So depends on what question that's given to us, this number will change. So you have to pick the correct number here. Right. Sometimes, if you look at the next part, sometimes your area is not going to be bounded. So here, like, oh, this part is like, oh, look at the probability of z-score, that's less than some number, but not greater than anything, it's just less than some number. So that means it goes on one direction forever. Same here, right? So maybe there's a typo here. We're gonna do, it should be like this way. Sorry about that. So if I were to draw the graph of this left, the first one, it'd be like this. So whatever C is, it says z-score is less than C. That means anything to the left is less than C. So like we're talking about this area. And technically it goes on forever, right? same here. If I want to look at probability z-score is bigger than c, so I don't know where c is, I'm going to make it up. C is here. The bigger than c is like this way to the right, but it goes on forever. So there are cases where it goes on forever either to the left or it's to the right. It's not bounded. So in this case, what we're going to do second, then we're going to go to vars, which is the distribution. Kind of same thing, normal CDF. CDF, right? So lower, upper, mu, and sigma. So in the first case, when things are going to the negative infinity, unfortunately our calculator doesn't have negative infinity sign. So what we're going to do is we're going to just put in some big negative number like negative million. So what I'm going to say is either put negative million for negative direction infinity. So it could be like this, dun, dun, dun. Or if it's going to the positive direction forever, basically it goes to infinity, positive infinity, then I'm going to put some big number like positive, like a million for positive infinity. Right, so either put that or that, depends on what the situation is. And the mean and the sigma is whatever is given to us. All right, I'm going to do one problem on number 9. I'm going to have you finish, have you try a bunch of them. So let's look at part B. So here I'm going to find the probability, which is basically the area. The z-score is bigger than negative 1.23. So first of all, negative 1.23 is somewhere here, maybe between negative 1 and negative 2. And it says z-score is bigger than that, so it's to the right. So the shade to the right. And there's no other bound, it's only a one bound. That means it goes on forever like this. So I'm shading, it goes on forever theoretically, right? Okay, so what I'll do is normal CDF. And lower, upper. So this is where I only have one bound. I have lower boundary here, negative 1.23. But I don't have upper bound, which is positive infinity. So I'll just put a million. Or it could be any big number. The mu is equal to 0 and sigma is equal to 1. And before I get the answer from the calculator, I'm just looking at this. It's definitely more than 50%. This is a lot, so maybe like 80%-ish. It's almost 100, like not almost 100%, but it's pretty good percentage, right? So I have an idea what answer I'm supposed to get. So if I plug all these numbers into the calculator, I get 0.891 if I round off. So it's about 89.1%. So it was almost 90%. So I guess maybe high 80%, but actually it was almost more closer to 90%. So I have an idea what 9% kind of looks like. All right, I'm gonna have it pause now and then try number 9, part A, C, D, and we'll meet back at number 11. All right, we're back at number 11. So this is case more realistic case. So this is a more realistic case. Because so far we talked about the case where we have 0 as a mean and 1 as a standard deviation, but in real life it's not the case. Like for example, if I look at your exam scores, the mean is not equal to 0 and standard deviation not equal to 1, right? It means probably like 70 or 80, something like that, right? So what if that's the case? So number 11, if that's the mean is not equal to 0, standard deviation not equal to 1, we can still use it. We'll do n and then just mu and sigma, right? Instead of 0 and 1, we'll take whatever mean it is and then whatever the standard deviation that is given to us. So in that case, if you have to calculate probability of between A and B, what we can do is we can convert all the scores into z-score. Again, z-score is you basically take the x, subtract the mean, right? And divide by standard deviation. So you can convert things into z-score, and then once you have z-score, we know how to use it because it's normal CDF with the mean 0 and standard deviation 1. But in practice, we can't just work directly with the numbers that are given to us. So let's see, let's look at number 16. suppose the IQ is normally distributed. Okay, I'm gonna underline normally distributed, and then mean is 100, so notice it's not 0 anymore, and standard deviation is 15, so it's not 1 anymore, right? So part A, find the percentage of people IQ is lower than 105. So if I were to draw the graph, 100, it says 100 is the mean. I'm going to put 100 here. And 1, 2, 3. Again, I intentionally pick third mark, so it's basically the graph is flat, right? And I'm going to go by standard deviation. So standard deviation is 15. So the first mark is 100 plus 15, so that's 115. The second mark is 100 plus 15 plus 15. So I just keep adding standard deviation each time. That'd be 130, and then, so this is here, and then basically 145, right? So question says, IQ is lower than 105, so 105 is where? Somewhere here, right? 105 is here. And then lower than 105, so it's to the left. These are the lower number. Again, theoretically, it goes on forever. Here is probably stopping at 0. In this case, I guess it doesn't matter if you put negative infinity or 0. So I want to find the percentage of people. So again, I'm noticing that this is half, so that's 50%. It's more than 50%, so maybe like 60, 70, something like that. That was my guess. But if I were to find it precisely, so I'll do normal CDF. Normal CDF. Again, lower bound, I'm going to put 0 because IQ stops at 0, but I could have put negative million. I think you'd probably get the same answer. Upper bound is going to be 105. Mean is 100. And standard deviation is 15. So if I were to label it, this is lower. This is upper. This is mean. And this is standard deviation. And when you calculate this out, you're going to get 0.631 if you round off. So that's 63.1% if you want it as a percentage. So we knew it was going to be more than 50%. It happened to be 63.1%, right? So if the normal distribution is not standard, if mean is something else than 0 and standard deviation is something else than 1, we can still kind of go through the process. I just have to plug in the corresponding numbers here and pick the right lower bound and upper bound. Alright, I'm going to have you pause now and work on number 16, part C, and number 17, part A, B, and that'll be the end of part 1 of this section. In part 2, we're going to go back and finish the rest of the worksheet.